Sklearn Gaussian process kernels PairwiseKernel. The PairwiseKernel in scikit-learn's Gaussian process library provides a flexible way to define custom kernels based on a user-defined function that calculates pairwise distances between data points. This allows you to incorporate domain knowledge and create kernels tailored to your specific data and problem. Here's a detailed explanation of the PairwiseKernel. 1. Core function. The PairwiseKernel relies on a user-provided function, metric, which calculates the distance between pairs of data points. This function takes two input arguments: x1 a2d array representing the first set of data points, x2 a2d array representing the second set of data points. The metric function returns a 2D array of pairwise distances. It should handle both the case where x1 and x2 are the same, e.g., calculating distances between points within a single dataset, and the case where they are different, e.g., calculating distances between points in two different datasets. 2. Kernel calculation. Once the metric function is defined, the PairwiseKernel uses it to calculate the kernel matrix. The kernel matrix is a square matrix where each element represents the similarity between two data points. The similarity is calculated using a predefined kernel function gamma. Common kernel functions include RBF radial basis function gammad express d2 to L2, where d is the distance between 2 points and L is a length scale parameter. Laplacian gammad express dl. Linear gammad d. 3. Key parameters. Metric, the function used to calculate pairwise distances. Gamma, the kernel function used to convert distances to similarity scores. Common options are RBF, Laplacian, linear. Gammaquarks, additional keyword arguments passed to the gamma function. This allows you to customize the kernel function further, e.g., by specifying the length scale L for the RBF kernel. Core 0, a constant added to the output of the kernel function. This can help adjust the overall scaling of the kernel. 4. Example. Let's say you have a dataset of images and want to use the Manhattan distance as a metric for your kernel. You can define a custom metric function. Python. Import numpy as np. Def Manhattan the stance x1, x2. Return np, sum np. abs x1. None. x2 none. Access 2. Then you can create a PairwiseKernel object using this custom metric and an RBF kernel. Python. From sklearn, Gaussian process, kernels import PairwiseKernel. Kernel PairwiseKernel metric Manhattan distance. Gamma BF. Gammaquarksl 0.5. 5. Applications. PairwiseKernel offers great flexibility in creating custom kernels for specific applications. Domain expertise. You can incorporate domain-specific knowledge into your kernel function by choosing a metric that is relevant to your data. Non-Euclidean distances. You can use metrics like Manhattan distance, Hamming distance, or any custom distance function to capture relationships beyond standard Euclidean distance. Complex data structures. You can define kernels for data structures like graphs or sequences by creating appropriate distance metrics for them. 6. Limitations. Computational cost. Calculating custom kernels can be computationally expensive, especially for large datasets. Choosing the right metric. The success of your kernel heavily depends on the quality of your metric function. Kernel hyperparameter tuning. Finding optimal hyperparameters for custom kernels can be challenging. Elaboration on YAML values. You haven't provided a YAML file, but based on the PairwiseKernel parameters, here's an example of how you could use YAML to define a kernel. YAML. Kernel. Type PairwiseKernel. Metric. Type Manhattan distance. Function NP. SUMNP. absex1. None. X2 none. Access to. Gamma RBF. Gamma quarks. L0.5. Coa 00. Explanation of keys. Type specifies the kernel type, e.g. pairwise kernel. Metric defines the distance metric used for calculating pairwise distances. Type the name of the distance metric function, e.g. Manhattan distance. Function the Python code for the distance function. Gamma the type of kernel function, e.g. RBF. Laplacian. Linear. Gamma quarks keyword arguments passed to the gamma function. Coa 0 a constant added to the kernel output. Conclusion. The pairwise kernel provides a powerful tool for customizing Gaussian process kernels by allowing you to use custom distance functions and kernel functions. This flexibility enables you to capture specific relationships in your data and achieve better model performance in various applications.